In the last lesson, we talked about all of the log files being sent into a centralized SIEM or syslog server. Now we want to start performing some data analytics so we can start figuring out what's wrong with those logs or what might be triggering us. So the first thing we look at when we talk about data analytics is integrating all of the logs from all of our devices, because that's going to give us more value and more information. Yeah, it's great to look at my email server, but when I'm only looking at the email server and not looking at what's been coming through the routers, the switches, the firewalls, the data loss prevention system, and putting all that together, I'm missing the big picture. So we want to conduct manual log reviews, but that's really time consuming and we don't have enough people to do that. So we start using automated systems instead because they're better and faster at doing it. Instead of looking at all 1 million log entries that came in, I can instead let the computer do that and flag the ones that might be of interest and have you, the cybersecurity analyst, analyze those and determine what is of value and what isn't. Automated systems can help us prioritize these items for review based on heuristics or previous signatures created or the trends that we've observed in the past. Now, you need to conduct data aggregation and correlation, trend analysis, and historical analysis to be able to figure out the best information from your data that you've been collecting. Because if you collect all this data and never look at it, it's not going to do you any good. So the first one we want to talk about is data aggregation and correlation. This is a really important concept because on the CSA Plus exam, you may see some questions that ask you to correlate the data. They'll give you some logs from a system, from a network device, from a router, and you'll have to look across and figure out what's going on. That's an important concept, right? So you want to combine the data from multiple sources and events, and then you can see what the impact is to the larger environment. You'll be looking at things like syslogs, authentication logs, application logs, event logs, and other things in a central analysis node. And one of the great ones here is Splunk. I really love this product. It does a great job of taking all of this information, dumping it into a database, and we can do big data analytics and correlate that information across time and events. This is what's known as a detective control because we're going through and being a detective and looking through all this information to see what we can find. Splunk is a great product for this. There's numerous other ones out there. Splunk just happens to be one of the ones I've used a lot in the past. Now, trend analysis is when you analyze the system, events, and devices to detect trends and patterns. This is going to help you identify issues that are outside of the expected normal growth or usage patterns. So you may be asked on the exam to look at some trend and see what's standing out as wrong. For example, I might give you some logs from a server or a router that says, here's what the normal bandwidth is, and here's what the bandwidth was last week. What's wrong? And maybe it's normally at 3 gigabits per traffic, and this week it's up to 11. That's something you want to investigate. Why did it grow so much? Is somebody stealing a bunch of information from our network and that's causing us to have that issue? Well, we don't know, but you need to investigate that, right? And so by using these logs across the enterprise, you can start looking at that. Splunk, again, does a great job of that. I have a screenshot here showing you those patterns. You can see how they rise and fall and look at them over time. Now, how is trend analysis different than historical analysis? Well, historical analysis looks at all the same systems, events, and devices over time to detect the patterns and trends. But the big difference here is that it's usually done over a very, very long period of time. And oftentimes you're looking in the rearview mirror with historical analysis. With trend analysis, you're looking forward based on your past history. But in historical analysis, you're looking backwards because something bad already happened. So maybe we just found out that someone had stolen our top secret plans for our next company's function. Well, we're going to start going back and pulling the thread and figuring out, based on historical analysis, who touched that file, when did they touch it, where did that file go, who emailed it out, and we can start looking back at that stuff over a very long period of time based on the information we have in our database of all of this correlated data.